Hello everyone. Right now, I don't know if you noticed, but we have artificial intelligence that is changing a lot of things. And this is the first video of a very long series. In here, we will focus on a specific type of AI. We are going to talk about image generative AIs. A kind that will disrupt many fields, like advertising, video games, cinema, and many others. We are going to talk here and there about other types of AI, but this series is mostly dedicated to AI art and image generation. And we will use this opportunity to learn at the same time more about ComfyUI. Some say that ComfyUI is an interface for stable diffusion. But today, it is much more than that. What started as an alternative to other interfaces is now a real and complete environment. ComfyUI is open source, has no real competition, is unique in its kind, and has become the reference in the field of image generation and modification. Its relative complexity gives it a particular flexibility. ComfyUI is also capable of modifying videos, sounds, with an infinite amount of customized nodes. We will, of course, focus mostly on my customized node, what they are capable of doing for you and how to use them. But you can also create and program your own nodes, even if it's not the subject of this video. This video is an educational video whose goal is to teach you how to use ComfyUI. I will not give you ready-to-use workflows. What matters here is not the final result. My goal is to give you a clear and precise understanding of ComfyUI, the nodes, and their effects. This video is also not a course on stable diffusion, even if I will obviously talk about some basics. I will not go into certain technical details or vocabulary if they are not important inside the ComfyUI environment. It means that you are going to use some things that you won't understand fully, and it's totally fine. To drive a car, you don't need to understand all the mechanical components and their interaction with each other. I will, therefore, sometimes voluntarily simplify certain technical subjects. My goal is to stick to a practical use of ComfyUI. My goal is not to show you how to make the best possible images. If you want to make something beautiful, just copy-paste a good prompt. If you are waiting for that, this video is not for you. This course is also not about prompt engineering, even if I will, of course, talk about it a little. This course may seem long, but I really made this to be as fast as possible. So here is a preview of what we will see. Preparing our Python virtual environment, installing and configuring ComfyUI. We will learn to navigate and interact with the web interface. Understand the color coding, the basic logic of the nodes. How to organize and structure your nodes for a reusable workflow. We will learn how to create images with SD 1.5, SDXL, SDXL Turbo, SD3, and Flux. We will understand the limits and the advantages of each of them. And no, there is no obsolete model. We will use our basic knowledge with a practical example. Modifying the textures of Mindtest, an open source video game. We will see a large number of customized nodes and how to install them, especially mines. We will see how the manager can help us get organized. We will try to edit an existing image. Transform any image into an ultra high definition. we will implement automatic AI detectors. Change, repair, or improve faces. We will change, repair, or improve hands, with, of course, the possibility of separating the characters and giving them different characteristics. We will talk about how to use LoRa's, ControlNet, and IP adapter, including, among other things, style composition, face changes, and so on. We will see how to animate and make a previously created character talk or sing. We will see how to manage the transparency of images inside ComfyUI, how to remove the background of images and reuse them, how to integrate a large language model directly into our interface. We will understand a lot of concepts, like checkpoints, sampler, scheduler, steps CFG, denoise, and many others. We will learn to test different configurations. We will transform a very basic drawing into a caricature and do manual painting to correct errors. Even if this course remains mainly focused on intelligent automation and not really on a particular artistic creation. But I will at least show it to you how to do it once. We will test the adherence of several models to the prompt, so you will quickly understand the capabilities of each of them. We will understand the hardware limitations you are going to encounter. We will see how to edit the appearance of ComfyUI. We will see how to use ComfyUI as a backend and the importance that it has. I will show you a script of mine that I use directly in my file manager. I will also show you one of my fork of Logjet to integrate ComfyUI into it, so you can directly generate your images with your workflow in a chat window with another artificial intelligence. We will do a tiny bit of programming just to practically show you how to use ComfyUI in the command line. Really just a little bit. We will just edit a script. I will not go into details. In general, we will see how to solve our problems. I will make sure to fall into as many traps as possible, so that you can identify them quickly when you encounter them yourself. And of course, a lot of other small details that I will not list here. For me, this video is perfect for getting familiar with ComfyUI. You will also be able to get results quickly. But my goal is, above all of that, I really want you to be able to create your own complex workflows. And hopefully, you will be able to achieve results that will already be much better than the basic examples of this video. Since this lecture was recorded, some minor visual changes have happened inside ComfyUI. For example, to go back to the original workflow, you should now click on Workflow and then Browse Template. And here you have a button to load Default Image Generation Workflow. And now the settings are on the bottom left. And you can see the option in light graph, the one we're going to see later. Remember, overall, that this field is evolving very quickly. I will focus on teaching concepts that remains relevant, but some details may change in the future. I will do my best to keep you updated. Now have fun and enjoy the first video. On Linux Ubuntu, the first thing to do is to install Python, Python pip, and Python virtual environment. Let's start by going to the ComfyUI GitHub page. By clicking these green buttons, we will copy the project link. I've prepared a folder to put ComfyUI inside. So we will do a git clone of this project. Of course, you need to have git installed. To install git on Ubuntu, you can do sudo apt-get install git. But I already have it. Then we will enter this folder with our file manager. We will create a Python virtual environment for ComfyUI. We will use venv for that, so you will have to choose where you want to put it. I have a venv folder that contains all my Python environments. The goal of this isolated environment is that all the packages you install won't create compatibility issues with the rest of your system. So you can do whatever you want, it will not make your system unstable. Now we will activate this environment for the terminal that's currently open. Without doing this, it won't work. ComfyUI won't find what it needs. In my terminal here, you can see that after the source command, I'm on Python 3.12.3 and my environment is myComfy. In this guide, I will only talk about NVIDIA cards. So you will need to install the appropriate drivers and CUDA. By doing NVIDIA-SMI, you can see here that I'm using driver 550-9007 and my CUDA version is 12.4. And now we'll go back to the project page and find what we need to install. I will simply copy this pip install code. And I will paste it in my terminal that's using my virtual environment. Now that it's done, we will quickly look at the size of our virtual environment. And the size of the ComfyUI project. Depending on what you plan to do with it, you will need a lot of disk space. Most models are 6 GB each, at least for the 1.5 models. So if you are low on space, think carefully about what you want to store or not. We will enter the project folder and install dependencies with pip install-r requirements.txt. And finally, we can launch ComfyUI with python main.py. If everything goes well, you should see something that looks like this, without error messages. If you see something weird, it means you missed something. Here you can see a link that you can access locally in the web browser of your choice. And here we have our first ComfyUI workflow. A default example is provided. So ComfyUI consists of nodes that you can connect together by colors, using lines that look like colored spaghettis. As you can see here, yellow goes with yellow, pink with pink, blue with blue, and so on. Each color represents a variable type. Blue is for one or more images. Red is for VAE. Pink is for latent space, and so on. It is not important to know what these words means, at least not for now, but you need to know that they are not compatible with each other. ComfyUI simply won't let you connect two colors that don't go together. And without wasting time, let's try to launch this workflow, or this set of nodes, by clicking on qprompt. And right away, it doesn't work. We have an error message. ckpt_name means just that there is no model. And you can see here in red the node that is causing the problem. And it is from this node that everything starts. Load checkpoint. In all these nodes, you have inputs and outputs. The inputs are on the left side of the node, and the outputs are on the right side of the nodes. You can see that load checkpoint has no input. So ComfyUI considers this node as the first node, and it will give more information to other nodes. Here it will send 4 spaghetti lines. 1 purple, model, 2 yellow, clips, 1 red, VAE. When a node is selected, like right now, load checkpoint, you can see that the spaghetti turns white, which makes them easier to distinguish from others. So we are going to immediately download a model to give it to ComfyUI. We will go to Civit AI, which is the de facto reference. We will start with the simplest and fastest type of model. So we will filter with SD 1.5, which is Stable Diffusion 1.5. And we will take a model almost at random. Let's take a photorealistic one. We will download it. This one is 4 GB. You also have a lighter model, lighter version of it at 2 GB. To download from Civit AI, you will first have to log in. Once you've downloaded your model, you can put it in the Models and Checkpoints folder. Then you can return to ComfyUI, refresh the page with F5, for example, and you should be able to select your model from the list. And we will launch this workflow again. This time it's green, and at the end, we have our image. So in this video, we will download several models. So let's immediately classify them in folders. This is a 1.5 model, so I will create an SD 1.5 folder. After refreshing, you can still select this model, but now we will clearly see 1.5 in the selection line. And of course, it still works. Load checkpoint is therefore the initial node. And you can see with the green outlines which node is currently executed. The case sampler node even has a progress bar, because it is most likely going to be the slowest of the bunch. It is our main node, if you will. It is the one that will create the image. The last node will simply save the image that was created. You can see that the Save Image node has no output on the right. It is like a dead-end node, if you will. Here, the workflow isn't very complex, so this node is simply the last node. When the image has been saved by this node, the workflow stops. Let's look at the nodes. You can see that I can move them wherever I want. And all of that doesn't really matter. It is just a visual change. The fact that load checkpoint, the first node, is on the left and that save images, the last node is on the right, is just a convention. And honestly, also a good habit to get into. But you can move and resize your nodes however you want. In the menu, you have options. I won't talk about everything, but I will change grid size to 25 and put another kind of spaghetti, a little bit more al dente. Let's refresh the page. Yeah, well, it's rather raw spaghetti now, but whatever. That's all about everyone's taste, so use what you prefer. So when you select or move a node, you see that the links become white. The grid size that I changed earlier allows us to hold down the Shift button to align our nodes more neatly. Same for resizing. You have a Load Default button in menu that allows you to quickly return to the default workflow. Note, however, that it still keeps the model I downloaded in the Load Checkpoint node. If it finds a model, it will use it. But yes, it's not because you see a file name in a node that you necessarily have this file on your computer. You will quickly realize that if you use workflows from other people. So for the nodes, you have here a clip text encode node. It will take as input the yellow clip from Load Checkpoint. It then transforms this yellow input into an orange output, which is connected to the positive of the K-sampler node. This clip text encode node is just going to contain a description of the image you want to make. You have the same type of clip text encode node that connects in orange to the negative of the K-sampler. It's basically what you don't want to have in your image. If you want something to appear in your image, put it in the positive. If you don't want it, put it in the negative. You also have a node without input. This will just create a pink latent space that you can send to the K-sampler. Here you can think of it like a 512 by 512 empty image. But be careful, the K-sampler can't use blue, only pink. We have our K-sampler node, which contains a lot of options that we are going to see later. We have a VAE decode node that will use the red spaghetti and the pink one to make a real image with the blue spaghetti. This real blue image will then be sent to the Save Image node. Notice that this node also gives you a preview. For the name of the image, you can give the prefix of your image, after which ComfyUI will add numbers to the name to just make sure you never lose images. So we already launched this workflow twice. We should therefore have 2 images. These images are stored in the output folder. Here we see our 2 images. Here you can see that these 2 images use the default text that was given, a purple galaxy in a glass bottle in nature. But other than that, the images are completely different. You can launch this workflow as many times as you want, and you will always get something different. Well, not exactly an infinite amount, but 4 billion of them. So this node sends a latent space, so a pink latent space to the K-sampler. You can just give it the size of the image you want to create. Let's change 512 by 512 to 1024 by 1024. Here you can notice that the K-sampler takes longer to give us a result. Here, of course, it will be 4 times longer, with 1024 instead of 512. So I guess you understand that, and 1024 by 1024 image is 4 times bigger than a 512 by 512. But what is interesting here, it isn't really the size of the image. It's interesting because we don't really have what we thought we would have. In 1024, the image exists, but there is clearly a problem. We don't have a galaxy at all anymore. Now it's the flowers that are purple, not the galaxy. The bottle is weird too. So there is clearly an issue. Let's continue to increase this size. Let's try with 1532. Here you can see that the number was automatically changed to 1536. This is because Stable Diffusion can only make images that have a multiple of 64. So in this case, the closest multiple of 64 is 1536. By increasing the size even more, we see that it is even more nonsensical. Do you remember when I told you that this was a Stable Diffusion 1.5 model? Well, version 1.5 is made only for small images. 1512 by 768 will work, but more than that, I just don't recommend it. You will run into problems. Let's try with 512 by 768. And here the result is not that bad. Let's do some cleanup before continuing. So here you just need to type in English what you want to create as an image. Let's create the portrait of a troll. I like this one. Here you can see green eyebrows, which is a bit weird because I didn't talk about colors in my text, like the purple galaxy, for example, from before. But if you give the model a very restricted text, like the one I just gave, without any details, the model will have to imagine a lot of things. And it turns out that green is a color that comes up often when talking about trolls. In fact, these models train on millions of images, and to simplify, they will just mix them all up and create a unique image. Here we can see that in a large part of the training images, trolls are probably green. Maybe they have a green skin, maybe they are in the forest. In any case, the green color is apparently often there in the training data. This is why now we have green eyebrows and green eyes. But we don't really care about that. I'm not going to talk too much about the text. Here we are mainly going to learn how to use ComfyUI. So we are going to completely delete everything and start from nothing. We are going to learn to add nodes one by one and connect them one by one. This time, we will start with a load image node. And we will modify this image. And we will get the passport photo of our friend troll there. Here you can see that this node will give us a blue and green output. The blue, like I said before, is like a normal image, if you will. The green, we won't care about that for now. We will add our load checkpoint node. And you can see that by grabbing and dropping the color point, I have a menu that offers to create a node that could attach with that color. And here we quickly have our case sampler with our purple spaghetti that connects them. And just like the basic example, we will create our two clip texts and connect them. But this time, instead of sending an empty image to the K-sampler, we will do a VAE encode node. VAE encode is what will allow you to transform a blue image into a pink latent space. Convert it if you prefer. And after you decode, you can use the red VAE of the model to make a blue image. And this time, I will just put a preview without saving the image anywhere. We are going to make a lot of tests, so preview is very good for us. Especially since we are really not here to make quality images. We will put back a text, once again something simple. Portrait of a troll. And here we will see our first K-sampler option, denoise. Originally it's at 1. You can see this as 100% change, which is logical when we send an empty latent space like we did before. If the denoise is set at 1, it will change 100% of the empty image, which makes sense because we don't want to keep anything from the empty image because it's empty. But in this case, with a load image, we will put it at, let's try 0.5. You can translate this as basically change 50% of the image. It's not really about percentage, but I'm simplifying here. So to make it clear, if the denoise is at 0, it will be exactly like the input image. And if the denoise is at 1, it will be completely different. So with 0.5, we still have the same image, but with a lot of changes. We can quickly test with 0.8. It will give us even more changes. And with 1, nothing similar. The skin is even blue now. And with 0.1, it is almost like the original image. So if you like an image, you can apply changes to it without them being too violent. It's really your choice. Try and use the denoise value you want. When you finally like a specific workflow and you plan to reuse it someday, you have the possibility to save it in a JSON file. You can, for example, create a folder to put your workflows in. But what's interesting is that you can drag your workflow into your web browser and it will magically appear. Now we will look at this node, the negative clip, where we give to the K-sampler what we don't want to have in our image. Sometimes it just isn't used. But here I will try to get rid of the green eyebrows. I don't want this green, so in negative I will put just green. And now we have a drama. The eyebrows are still green. If you listen to me carefully, you should be able to know why the eyebrows are still green. I will give you a few seconds to think about it. If you find it, congratulations. And yes, our denoise is still at 0.1. The node tried to not have green, but it also doesn't have the right to change the image too much. Let's try with 0.5. And now it's a success. We were able to get rid of the green for the eyebrows and for the eyes. Now we will try to do the opposite. We will try to give him a blue skin. So we will add a comma to clearly separate that, and blue skin. And there we have kind of a half blue troll. Let's try with 0.7. Even there, the skin is pinkish. But the troll has changed a lot. So of course, when you do this kind of stuff, the objective is to make slight changes, not completely change the color of the image. So, of course, if you want a troll with blue skin, make sure your original image is a troll with blue skin. Well, my objective here is mostly to show you, by an example, what this denoise variable does. And now the moments you are all waiting for. We are going to install my custom nodes. I'm going to do Ctrl-C to close ComfyUI and have access to my terminal. If you want to install any custom nodes, it will be exactly the same method. Be careful, however, you have to trust the creator of these nodes. Don't install anything if you don't trust the creator. If you have doubts, you can look at the code too. But me, you love me and you trust me, so it's not a problem. So I'm just going to do a git clone. Coming back to ComfyUI, you can see this reconnecting. It means that ComfyUI isn't accessible, which is normal because we closed it. So we can relaunch ComfyUI with Python main.py, and the reconnecting button should disappear. Here we are back on our workflow. But if we go back to our terminal, we have a new drama. We see here Bjornulf custom nodes import failed. And up there an ugly error message. It is time to install my dependencies. You don't need to install Ollama, but you need to install the Python packages with pip. So pip install Ollama. And I also have PyDo. To install Ollama, I will put a link in the description on how to do that. But that's another subject. We don't care about that for now. As of today, I have so many dependencies that now they are all inside the file requirements.txt. To install them all at once, you can just run pip install-r requirements.txt while inside the folder of my custom nodes. But it is still important for you to learn how to install them individually. So we can relaunch ComfyUI and magically we have no errors. But be careful, depending on when you are going to see this video, you might have to install other dependencies. So you should check out my GitHub page for all the new updates. I will probably do a lot more nodes in the future, so I will increase the number of dependencies. Check everything new on the GitHub page. By right-clicking, you can add nodes with Add Node. As usual, if you can't see something new you just added, you need to refresh the page. And there you have some of my nodes. Like I said, I will probably make a lot more in the future and improve a lot of them. The first node we are going to talk about is a loop node. You can see that which node is a loop node by this green recycling arrows. That means that this node will return more than one result. I will use this node to test a range of floats. Here it is for floating point numbers. When you right-click on the case sampler, you can convert a value into an entry point. Now, instead of having a value, you can connect this to another node. Denoise is of type float, like my loop float node, so we can connect them together. My node will generate a list of floats. This node contains 3 values: the starting value, the ending value, and the step for each pass, which I called jump. That means that it will do, in this example, 0.1, 0.2, 0.3, etc. up to 1. So we are going to send that to the K-sampler. Not one number, but 10 different numbers. And there you can see in the preview all our results with a denoise from 0.1 to 1. We can clearly see here the progressive changes. You can click on an image and use the keyboard arrows to navigate between them. Let's put aside this head of this overweight troll. Now we will look at this large number, the seed. I will copy it. Thank you, Opera, but this is not a credit card number. And I will recover this head too. I'll put 0.1 to make only one image, just to test. You see here that each time I launch the workflow, the seed value changes randomly. This line goes hand in hand with the one below, which is here randomized. We will put the seed that I copied earlier and change randomized to fixed. And we will redo the list of 10 images. And we finally return to our blue troll. So by using a specific seed on a specific workflow, you can recover a work you've done earlier. Or you can recover the workflow from someone else. You just have to use the same workflow and the same seed. However, be careful that the seed is generated after the generation, meaning that the seed you see corresponds to the seed of the next generation. Here you can see that the seed wasn't that of the overweight troll. It's important to note that ComfyUI also keeps a lot of things in cache. You see that ComfyUI refuses to relaunch a workflow if it has exactly the same results. So here we will get rid of this loop and find a good value, as close as 0 as possible. Here it's 0.8. The skin color is good enough. By double-clicking on certain color points, you can create primitive nodes. Here we will put 0.8. Let's put it back to randomize. And there you can see that even with 0.8, it is not necessarily great for changing skin color. Again, this is an extremely stupid example to show you. Don't put yourself in this situation. Here I'm just showing you how to use the node. Making the color blue is extremely difficult without having a high denoise value. but we are just testing the nodes here. Now we will look at these two variables, sampler and scheduler. They kind of go together. I will test with dpm++2m SDE and Keras. You can see that the style of the image is different. The image will be different even if the seed is the same. I will not go into details about schedulers and samplers because this is about ComfyUI, and these schedulers and samplers are very dependent on the model you are using. In any case, you can test them. Some work better than others with different models. Let's go back to something clean. We are going to save our blue troll with the square jaw. And we remove everything. And just like we did with the workflow JSON file, you can take any image that you created with ComfyUI and drag it into your web interface to reload the workflow that was used to create it. This time we are going to put a save image instead of a preview. And here you can see the seed that was used to create this image. And here you can see the cache effect. ComfyUI retrieved the images from cache to save them directly, without relaunching the creation of these images. And I'm going to prove to you that it is the same image. And as always, ComfyUI doesn't let me relaunch the same workflow if it's not necessary. And here it isn't. Now what else? We are going to start fresh again. With the portrait of a troll with blue skin. As I told you, it is much smarter to start from there. And now we are going to create a 1024 pixel image. Here you see that, like with the bottle, the result isn't really good. And now we are going to move on to more serious things. We are going to download an SDXL model, which are capable of generating 1024 pixel images by default. So this time I will just select SDXL 1.0. And here it's perfect. We have the sidebar realistic for SDXL. Same thing, we will put this in models and checkpoint. We will create an SDXL folder to not mix them up. So we are going to take the default workflow again. But this time we're going to use our SDXL model and a 1024 pixel image. We learned from the mistake from before, so we will immediately put blue skin and not green. We're going to leave everything default and launch that. Let's try another one. I don't really like this one. It looks suspicious. This one I like. it's a monster, but it looks rather friendly. Now that it's saved, I'm going to clear everything up again. I'm going to clean my tabs too. And we will try to increase the quality of our image. So to practice a bit, we are going to redo our nodes manually. We are going to load image, our neutral, and do all the classic nodes. You should know them all by now. But it is a good practice to redo this workflow manually. It is the base of everything. This time, prepare carefully our clip text encode positive node, and same for our negative. And at the end, I will of course use the VAE decoder to recover the real image. I will put the denoise at 0.7 and try that. Here, very easy fix. You can see the problems with the node. It is circled in red. And here I just forgot to connect the model. And here our result is quite ugly. We will try with 2M Keras. And it's even uglier. We are going to add a keyword to make it diabolic, so the word evil, and try again. No, this is still ridiculous. Once again, if you have been listening carefully, you should be able to understand why these images are so ugly. I will give you a few seconds to think about it. And congratulations again to those who figured it out. Yes, I haven't selected the SDXL model yet. We are going to select that and relaunch the workflow. Oh gosh, that's a little too diabolic. Let's see that with 0.3. Okay, so I like the original image, so I prefer this one. 0.3 is good. It's a bit more diabolic, but not too much. And now we are going to try to increase the image quality. We are going to start by creating the structure. We are going to send the latent space to another K-sampler and connect the other colors. This is what it looks like. But we are going to increase the size of the pink image there. So we are going to put an upscale node between the two samplers. You can use either a specific size or a size proportional to the input image or input latent space. We are going to use upscale latent by 1.5, so 150% of the original size, which will bring us to 1536 pixels. We are not going to put the denoise at 1, of course, but we will try 0.3. This will take longer because the image is bigger. And now we have the same image, but with a better quality. This is what is called high-res fix. With this method, you also have the possibility to fix certain errors, like a face that is too far away, for example, it will not have a good definition. You can fix that, but you can also create new details in the image. We are going to make an even bigger image, 2048 pixels, with 2 as multiplier. It should take about 30 seconds to create this image. Once again, the bigger the image, the longer the generation will take. That's why in this series I will show you as much as possible stuff done with SD 1.5, because it is much faster. Just because the image has more pixels doesn't mean it will be better. Once again, there is a limit depending on the model. But all of this is for you to see and test. Let's go back to something clean. And here I'm going to create a swamp monster. I'm going to stay on SD 1.5 to generate quickly. I don't care about image quality. We are just testing nodes here. What we did with denoise, we are going to do the same things, but with steps. By default, it's 20, but we are going to test that value. You see that by dragging steps, you have my integer loop. An integer is just a whole number, meaning a number without decimals. These two are two different nodes. Be careful, you cannot connect an int to a float. So I personally have two different nodes, a loop int node and a loop float node. In this loop int node, we are going to make a loop that is going to go from 1 to 20. So 20 images. One image with 1 step, 2 steps, 3 steps, etc. up to 20. And here we immediately see with my node that below 10, it's really not that good. So we can try with 1525, so it will be more relevant. Okay, 25 looks good. Now we are going to look at this CFG variable. Again, this time it's a float. You can connect your nodes however you want. Either you drag them or you create and connect them. It is the same. We are going to put the variable back in widget. No need for the primitive node here. We can keep it, it will be the same thing, but here I'm doing it clean just to test CFG. So for CFG, we are going to test the value from 1.00 to 8.00. And here, just like with steps, we see that it doesn't work at all with a CFG below 5. So this is not a general rule. This all depends on the model you are currently using. Some require specific steps, CFG, scheduler, or samplers. But again, don't hesitate to use my loop nodes to test all of this. This time I changed the text to try with swamp troll. We are going to stay on a CFG of 12 just to test. A CFG of 12 is very high, but basically the higher the CFG, the closer the image will be to the text you give it. So generally, the more details you give in the text, the higher you want your CFG to be. Again, this is not a general rule, and there are exceptions, but everything depends on your model. For example, here we are going to cover it with moss. With a CFG of 12, the image will be more inclined to respect what you are asking for. Okay, so we run several tests, so we are going to stay on these values that I liked, 25 for steps and 12 for CFG. We are going now to connect a new node with a loop of all samplers. The logic is the same. So here you also have the option to select only one sampler. But you can select all for a normal loop. Here we are going to test them all, 20 of them. I am on SD 1.5, so it should go pretty fast, even for 20 images. So here you see that each sampler, even with an identical seed, will generate radically different images. Also in their styles, the difference is striking. Style can also be done inside the text, but you see that the sampler also intervenes. And you can see here that some samplers are completely incompatible with the scheduler I have right now. So imagine there is a style you like, let's say LCM. You can now connect another loop node to test LCM with all schedulers. There are only 6 here. Here again, you have 6 different types you can choose from, once you have this list of style configurations: steps, CFG, sampler, and scheduler. You can start generating all the images you want on all the subjects you want, and they will share the same style. So there you have it. We've seen all the basics of the K-sampler node. Let's go back to our basic workflow. Now let's go back to SDXL. As always, I'm going to keep 1024 by 1024. And we are going to make a swamp troll with SDXL. And now we are going to talk about positive text in more details. As far as text is concerned, this is the most important node. We are going to try to give him more details, and we will see how SDXL manages and respect what I'm saying. I'm asking for a red witch hat, but the clothes are red. So I'm going to specify that I want a blue shirt. But now the hair is red. So I will specify it. Black hair. Not bad. Let's add yellow pants. This is where it all goes wrong. The shirt becomes yellow and the pants are black. There is also a red streak in the hair. Let's try again. Now it doesn't even have a shirt, but it's blue. The skin is completely blue, by the way. I'm going to ask for green skin specifically. Now nothing is right. The skin is still blue, he is shirtless, and the feet are grayish green. Let's try again. Now it refuses the green skin. The nipples are red, and no more shirt. So there is a method to tell Stable Diffusion that certain elements of the text are more important than others. You can surround them with parentheses. Let's try that with green skin. So the feet are green, I consider that progress. The more parentheses you put, the more weight the content will have in the final result. Let's try with 2 parentheses. Now shades of blues are everywhere, but it's not what I want. Let's try with 3 parentheses. Now everything is in this greenish tone. I'm going to add bright to specify a bright green color. It helped a bit, but it's still awful. Now we have 2 different skin colors. Let's go back to a simpler prompt. It seems that we are not going anywhere here. And here the result isn't bad on the first try. So sometimes with a precise prompt, we don't get anything good. At least with SDXL. So we are going to move to another model. SD3 Medium. This version is the base version. It is very likely that in the future you will have modeled based on SD3 that will be much better than the original. Once again, we are going to download that and put it in the checkpoint folder. To simplify your workflows, I advise you to take the one with clips and FP8. It's about 10 gigabytes. And I will retrieve our default workflow. We are going to refresh the page and select SD3. The resolution is the same. We will stay at 1024. And let's test with the basic workflow. And it's not bad at all. Now we are going to try to make our troll with all the details. Here we have some kind of cartoon, but you can see that SD3 manages to strictly respect what I give it. It is infinitely better at following the prompt. I'm going to specify photograph to not have a cartoon. Here we clearly see the superiority of SD3 for this prompt adherence. Here I left everything by default, but good values for SD3 are steps 28 and CFG maybe something around 4.5. We are going to put DDIM and SGM uniform. Again, you are free to test, but here it will take too long to generate. Because of course, the heavier the model, the longer it takes to generate an image. The logic of the nodes are identical as with SD 1.5. So if you want to test, you can do that by yourself. Okay, this one is cute. So we are going to change a little bit. There is an SD3 node for empty lighted space, but I suspect it doesn't do anything particular. I haven't looked at the code, but maybe one day it will do something, so maybe it's good to know that it exists. And another node that is specific to SD3, but which is quite important, is this model sampling SD3. It is based by default at 3. I will let you test different values on your side. There we already have an SD3 workflow that really isn't that bad. But since we are here to test, we are going to add a watch to it. Add a snake behind it. Let's add a tiny detail, see if SD3 is capable of catching that. We are going to put a skull on his belt. And yeah, no problem. Really today, the biggest advantage of SD3 is its ability to respect your prompt. SD3 is also capable of handling multiple characters quite well, without mixing them up too much. Something that SD 1.5 and SDXL are just incapable of doing. Does that mean that certain things are impossible to do with SD 1.5 and SDXL? Well, not at all. But your workflow will have to be more complex. But before seeing all of that, we are going to use our knowledge for a practical application. In the next video, we are going to create textures for a free and open source video game, Mindtest. Congratulations if you made it here, it was already a long trip. Let me know if you like my work and my tutorials. Go take a look at my nodes on GitHub and give it a star if you like. I'm waiting for your feedback on that as well. It's not perfect yet, but it's gonna be better and better with your ideas. If you like my work in general, tutorials or creations, I have a Ko-fi page where you can support all of that. Link in the description. If you have love to send, please do. You can contribute of my dream to buy 5090 there. The more I receive from you guys, the more motivation I have to continue. Anyway, I hope you will follow this series. But keep in touch, I'm working on a lot of different AI systems, and I'm going to improve a lot of stuff in the near future. Crazy ideas, crazy projects. I'll see you in the next one. Peace out.